Refraction of light examples. Refraction is the phenomena in which a ray of light gets bent due to change in the medium density. Refraction can be understood by the given refraction of light examples. Throughout this video, we are going to explain the concept with 10 real-world examples, which are: refraction can be seen in our eyes. An ice shows refraction. Refraction causes apparent flattening of the sun at sunrise and sunset. Refraction seen in water drops. Refraction causes an apparent shift in the position at sunrise. Refraction in diamond-cut glass. Rainbow is formed due to refraction. Refraction in concave and convex lenses. Refraction in a jar filled with water. Refraction of light is seen in a transparent digital video disc. Refraction can be seen in our eyes. The lenses present in our eyes show the refraction of light. Let us understand how refraction takes place in the eyes. The lenses present in our eyes are convex, and refraction occurs in convex lenses. As we know, all objects do not have their light, and they get lit up by any energy source. And when light falls on the object, it reflects the light, and hence we can see objects. The light which get reflected and strike our eyes goes through refraction, as our eyes have convex lens. And as we know, convex lenses converge the rays passing through them. When the bent rays fall on the retina of the eyes, it forms an inverted image. However, we see an actual image. This happens because our brain interprets the image, and hence we see real images. After that, our mind recorrects the image through the brain's nervous system. So the refraction phenomena are seen because of the convex lens present in it. An ice shows refraction. Solidified water is ice. We use ice in our daily life. Suppose we make crystal clear ice and try to see through it. We cannot see things correctly, even if we use crystal clear ice. This happens because refraction. Let us understand how refraction occurs in ice. When light passes through the ice, it goes through refraction. When a ray of light traveling in air enters a block of ice, there is a change of medium from gas to solid. And due to changes in the medium, the light ray goes through refraction, which means bending the light ray. There is also a change in ray velocity while going through solid, which is a decrease in its velocity. And due to change in velocity and change in the medium, the ice shows refraction. Refraction causes apparent flattening of the sun at sunrise and sunset. We all have wondered why the sun appears to be flattened at horizon. This happens because our atmosphere also goes through refraction. While moving up on altitude, the density, as well as refractive index, falls. Because of this, the light rays from the top and bottom areas of the sun faces refraction at different angles. And due to this, the sun appears to be slightly flattened at the horizon. However, the rays from the sun, even on a horizontal plane, refract an equal amount of rays from its side edges. Due to this, the sun appears circular along its sides. Refraction seen in water drops. We all have seen water droplets. They are in spherical shapes. And water droplets themselves consist of several other small particles. Refraction in water droplets occurs due to their shape. The spherical shape of water droplets itself acts as lenses due to the spherical shape. When the light ray falls on the water droplets, it goes through diffraction, reflection, and refraction. Here let us discuss refraction only. When a ray of light falls on the water drops, it goes through a medium and velocity changes. This change occurs due to a change in the refractive index of the medium. And due to this change in its refractive index, it goes through refraction. Refraction causes an apparent shift in the position at sunrise. While going on the high altitude, the refractive index and the density of the air layers goes on decreasing. The light rays from the sun travel a long distance while going through rarer to denser mediums, which results in more bending to normal. But for an observer standing on Earth, the sun appears to be in the direction from where the rays are coming. Due to this, the sun seems to be over the horizon for the person watching it. But in reality it is not so. Due to atmospheric refraction, the position of the sun seems to be displaced. This refraction occurs due to its density variation from higher altitude to lower altitudes. The displacement of sun is about ½ degrees. This shift causes changes like, sunrise appears to be 2 minutes early, and sunset seems to be 2 minutes late. This causes to increase the daytime by 4 minutes. Refraction in diamond-cut glass. We all have seen diamonds, and they are so shiny and reflective. But they too undergo refraction in them. The diamonds are cut to reflect most of the rays entering them. In addition to this, the rays also undergo refraction, as when the light rays enter the diamond, there is a change in the refractive index. Here the light rays change their medium, which means there is a change of density when it enters the diamond. The different color, and shine of diamonds are due to refraction. When a light beam enters a diamond cut into a particular shape, the light rays go through numerous reflections. Due to this reflection, the diamond shines. As there is a material change, the reflected light also bends repeatedly. Rainbow is formed due to refraction. As we know, in our atmosphere, their micro-water droplets are suspended all around. On a rainy day, when the moisture content in the atmosphere is high, and there is sunshine after the rain, we might see a rainbow. The rainbow occurs due to refraction, diffraction and reflection all collectively. Let us understand how the refraction causes rainbow formation. A rainbow is formed when the water droplets in the atmosphere face the light rays, then the rays get refracted. As we know, the water droplets are spherical, which itself acts as a lens and causes refraction. When the rays pass through the water droplets, there is a change in the medium, which means light travels from a less dense medium to a denser medium. This causes the bending of light. When it enters the droplet, this refracted ray is reflected, and then again, it gets refracted, causing the formation of a rainbow. However, a few conditions need to be satisfied for the formation of rainbow. The person seeing the rainbow must be in such a position that the sun is behind him. As much as the sun will be low in the sky, more the arc, we will be below able to see rainbow, and lastly, the water droplets that will cause refraction must be present in front of the person watching rainbow. Refraction in concave and convex lenses. Lenses are of two types: concave lens, convex lens. Concave lens. Let us understand how a concave lens undergoes refraction. For this, let us take a biconcave lens. For this, let us assume that only 2 rays fall on a biconcave lens. At 2 points, when the light enters these points to the lens, it undergo a change of medium, which results in the change of density. As we can see, there is a change in medium, so the rays bend. This bending happens away from the normal. When the rays exit from the lens at other points, on other side here again, it undergoes a change of medium, which is dense to rarer, and it again bends away from the normal. This causes the divergence of the ray passing from it. This is how refraction takes place in the biconcave lens. Convex lenses. Let us understand how a convex lens undergoes refraction. For this, let us take a biconvex lens. For this, let us assume that only 2 rays fall on a biconvex lens. At 2 points, when the light enters these points to the lens, it undergo a change of medium, which results in the change of density. Due to this, the rays gets bends. Due to this, the rays gets bends. As the rays enter from a rarer medium to denser medium, it bends towards the normal, and when the rays exit from the lens at other points on other side, here again it undergoes a change of medium, which is dense to rarer, and it again bends towards the normal. This causes the convergence of the ray passing from it. This is how refraction takes place in the biconvex lens. Refraction in a jar filled with water. When we see a jar filled with water, we find that the depth of the jar is less. Because this is called as apparent depth, and this happens because of refraction in the jar. Let us understand how this happens. When we look into the jar from up, we see that the depth of the jar is reduced. This happens because when we look into the jar, the light rays from our eyes are traveling from the lighter medium, which is gaseous. And when the rays from our eyes strike the water surface, it goes through a change of medium, air to liquid. The travels have a density change, and its velocity also changes. Let us understand this through the figure. When the rays from air strikes, the water surface go through refraction and the rays bend. Due to this bending, the bottom appears to be slightly uplifted, which seems to us apparent depth. This phenomenon can be seen anywhere where a container contains water or even a pool. What we see is the apparent depth, which seems like this because refraction. Refraction of light is seen in a transparent digital video disc. If we take a transparent digital video disc in front of a light source, the rays from the source enter the disc. This ray gets scattered in all directions in the digital video disc. Due to this, scattering of various light colors is also seen. In a digital video disc, the light gets scattered due to the material of which the disc is formed, as there is also a change in the medium of the light rays, which is gaseous to solid. Due to this change in medium, the light rays get bent. For refraction to occur, we must take a transparent disc, which means it is not polished from either side. Because in a transparent disc, the light rays get refracted from the edges. And due to this, light rays get passed through the disc from another side. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.